Hello and welcome to yet another exciting video. So if you watched the last episode, I went and copied we sniffed all of the serial data between the microcontroller and the flash memory chip. That is this data. It's very dense. Tons and tons of information in here. So what you do is you export it and you end up with something that looks like this. So it's got tons of data in it. It's got all these timestamps, and if I find my mouse, there you go. I've got all these timestamps in here, and what they do is they essentially write all the pages of the flash memory chip. After they're done writing all of them, they read it out to verify that they actually went and, what they wrote is what they actually stored. So they read it back out, and so that's what we're after. So I go and find all the read requests and remove those. Remove everything else, and we're left with this, which is all of the read requests. So next we process that into a nice flat file system. Apparently it's been modified outside, but anyways, I have it open on Beyond Compare. We'll show you that in a little bit here. So read a request that was command number 3, address 010. It's a 24-bit address, and then here's all the data. So this is all of our wonderful. These are all the variables that C shell stores when you hit that save to EEPROM. Then we've got a couple extra pages, and these are the ones that are interesting. These are the static pages, which contain all of the stuff that we actually care about. It's located at the first page of the flash and the second page of flash. So I'll go ahead and show you this. And apparently I have them both open, so yes. So these two are different files. These are both from the air version, DMOC645 air-cooled version. And this is with the not secure bit and the secure bit set. And if you look around in here, it's a little hard to find it, but only one bit changed in this entire thing. But you see the checksum over here went from, they have the checksum at the beginning. See how it says 22B4, and then the other one, here I'll use my finger, BD61, but then all the rest of the data is the same. See 48, 3B85, and then this checksum is 22B4, 48, 3B85. So it's all identical except for the checksum, because we changed one single bit. That's how you know that this is a cyclic redundancy check. If you just change one bit and it's just a regular CRC, just a regular checksum, it will only increment here by 1. But since we changed one bit and we get two wildly different checksums, that means it is actually a cyclic redundancy check. We also did the exact same thing for the water-cooled. So if you open up both of these are the water-cooled ones, with it not secure and secure, and that gives us more data because now the checksum is B351, and over here is 2C0F, which we need extra data sets in order to reverse engineer how they're calculating that checksum, which I'll show you how to do that in the next video. In this, we're able to bring up Beyond Compare, and I'm comparing the air-cooled secure and air-cooled not secure. Those are the two, that was the one bit that we changed. And if you look, 01, 00. So that was the one bit that changed. Everything else is identical. And then, of course, the checksum changed. And I can show you the, here's the other one as well. And you can see this is the water-cooled. So this is the one, this is my DMOC645 water-cooled version. And I changed one bit. It's right here. And you can see it became 0 when I turned off the secure. Actually, which is funny because it's actually backwards. See that one is, I've labeled these wrong, not secure. and use secure. That should actually be a 1 there. That should be the 1 and that should be 0. But it doesn't matter. This is the file name that's wrong. But you can see the checksum here is at the beginning of the file, not at the end like it normally is. So the ends are the same. So the thing that everybody's been waiting for, this is comparing the use secure versus use secure from the A versus, or for the air cooled, so air cooled, water cooled, and I guess technically that's wrong because I just found out that that bit is flipped, but it's okay, it doesn't matter. Somewhere in there it's flipped. But you can see there's a lot of things that are different, and that's probably because the water cooled one I've played with, playing with different settings and things like that. So we'll just ignore all those differences. But down here is where it gets interesting. So these two pages, you can see, if we look over here, you see that where it says 12. 12 hex is 18. And over here it's 11. 11 hex is 17. So that looks like our byte. Now if you look, I think what it stores in here is the trouble codes. And because we newly programmed the air-cooled version, it has no trouble codes, it's all Fs. Whereas this one's got data in there, so I'm pretty sure that those are the static history of trouble codes that it keeps. So that's just, you know, FYI. And it keeps 2 pages, and we see that during boot up in the in hyperterminal. It says like A checksum OK and B checksum's OK, and then there must be a third page somewhere that's where they store the defaults. So if there's a fault in the checksum here and here, then it loads that default page, which, given their addresses, this is at 0 and this is at 1. The next one's probably at 2 as the default page. So this should give us enough information. We now know where the byte is that we need to change. I'm pretty sure this is the byte right here. And we also know, well, we don't know the checksum, how it does the cyclic redundancy check yet, but we can reverse engineer that given the data that we've collected. Some other interesting things. If you remember in a couple videos ago, the date of the drive when it was manufactured was September of 2011. So if we were to put that into hex, that's 0455. And if you look, 0455, so that's where they store the date code, manufacturing. And it's not a fluke, because if you go back and look at that video too, the drive was serial number 7019, and if we put that in hex, it's 1B6B, and if we look around in here, in this area, what do we find? 1B6B. So this page is storing all the static stuff that was all the stuff that was listed in that the dot box variables that were read-only in CC shell are all stored in these blocks. So anyways, this video is pretty long. The next one will be reverse engineering the checksum. So stay tuned for that. Thanks for watching. Bye.